but we still want to make sure that even though we're in this really, really large online classroom, we still follow some basic rules. For example, just make sure to have respectful communication. So there will be opportunities for you to unmute yourself and answer questions and have some interaction with the class. Just make sure to make sure that communication is respectful. You are welcome to participate. You don't have to. You definitely can sit back and watch and sort of absorb the class today. But I really encourage you to participate. So in our XCamp classes, participation is expected. So I get to know all of the students by name. I ask them questions. They ask me questions. It's more of like a discussion. And so yeah, if you want to participate, you definitely can today. But if not, and you're a little bit shy, that's acceptable as well. And then if 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 you would like me to call on you, well, you're going to raise your hand in Zoom. But as well, since I don't know your name, if you could do me the favor and changing your Zoom name to whatever you would like me to call you by. So if you raise your hand, I'm just going to look at the Zoom participants list and look at the name listed there and call you out by that name. So you might want to double check that and make sure that's consistent with what you would like to me to call you today. So just to do a little quick warm-up exercise to see if we are all ready and sort of following along and ready to participate for today, if you could do me a favor and show me, do you guys know how to raise your hand in the on Zoom through the little icons? If you do know how to, click that button and show me that you know how to use it. Okay, lots. I see already. Lots and lots of people, almost 20 people right now raising their hand in Zoom. Awesome. Yeah, so along the way, thank you, thank you. Great, and you can practice lowering your hand now. So along the way, I'll ask some questions. If you would like to participate, just make sure to raise your hand in Zoom, and that way the little notification will pop up to me and I can see lots of options of people who would like to help answer some questions today. Okay, great, so let's get started. So let's talk about what we're going to learn. So this is a completely introductory course. There's no expectation that you know anything about coding or the Python programming language or other things like that. This is, you can have no idea at all. Maybe some of you do know a little bit of coding, but today I'm going to break it down from the very, very beginning and just expect that you know nothing at all. So don't worry today if you don't have any background in coding. So we're going to learn some very basic concepts about coding in general, but more specifically about the Python language. After that, we're going to talk about Python and how it works and what are the things that we can do with it. Also, we're going to spend some time to go over algorithms. So we're going to not talk necessarily about specific algorithms, but what is an algorithm? What do they do? What is their role in computer science? And how can they help us to solve some really big and important problems? And then also I'm going to mention some data structures. So these are just ways in which through our code, we can model the world with our code. And it's going to help us to sort of create some structure with the data that we're representing. So the first thing I want to ask you guys, and this is kind of a open question, is what is programming or coding? Well, programming is the action of telling the computer what to do step by step. So I almost like to think about it as like you're creating a recipe, you're creating a story, you're giving some instructions to the computer and telling it what to do. Now you might be a little bit confused and you might be saying, well, Teacher Brendan, what do you mean telling it what to do? You may not even know the types of things that we could ask our computer to do. And so we'll see in a little bit very shortly what we can do. And I'll often just call it coding, programming, coding. We can use those words interchangeably. All right. So in order to get our minds sort of thinking about the types of things that we can do with coding, this slide here, it gives you a couple examples to make you start thinking about the types of things that we might use in our daily lives and not really think about that there's code happening behind the scenes. Does anyone want to raise their hand and help me out to either explain one of the photos and say, hey, oh, I know what this is, and I think that it's related to code because of some reason. Or if you would like to, you can also come up with your own example. So you could say, oh, this is another thing that I know about or I see in my daily life, and it has to do with code. Okay, I see Evan had his hand up first. Evan, can you unmute yourself and help me out to give me an example?
I forgot to put it down.
Oh, you forgot to put it down? Okay, no worries. Let's go to the next one. William Yang, can you help me out? Oh, hold on. Let me click. Okay, you can unmute yourself. Go ahead.
The first thing we can do, I think, is like the first one. I think
Okay.
it's like strategy game. That's a picture of chess, and I think that we can use code to figure out like how we place our moves, like strategy.
Yeah, that's exactly right. So this photo here is like just a picture of a chessboard, but I'm not sure. Does anyone play chess online? Has anyone tried playing chess online or like chess on an app versus like an AI player or like a computer player or something like that? Yeah, it's really fun. I've played some chess with some ex-camp students. Sometimes we like to, I don't know if you guys know about like chess.com or anything. That's fun way of playing chess and improving chess. But the question is, so say for example, you're on this chess.com website and you're playing against this robot player. How do they know where to make the move, right? How is that even decided? Well, someone had to write some code to decide some logic for how that player should move. And even what's interesting to think about is, let's say, for example, you select like easy mode or hard mode or something like that. That may be different set of moves or different style of instructions to it, right? To make it easier or harder for you to play against. So I think that's an example of code that oftentimes, especially when we're playing games and things like that, we don't really think that someone had to create some instructions or logic for those decisions to be made. So yeah, that's an example. Okay, let's see who's up next. Ford, can you help me out? Do you have another example? Oh no, I think he just had his hand up. Yes, Stanley. Stanley, are you there? Maybe these are students who had their hands up from the very beginning. Okay, well, I'll try next hand up is I can see Jason. Jason, did you mean to have your hand up? Are you trying to help answer the question? No. Okay. All right, come on, guys. There's a lot of there's a lot of easy ones on here. What's this one in the I guess if we're on the theme of games, what's this one in the bottom corner? Oh yeah, Lee, can you help me out? I see you have your hand up. Okay. Well, in that case, if we're a little shy, that's okay. I'll help you guys out. So this one in the bottom corner is a game, and feel free to help me out with the name of this game. And oh yes, we have William. You want to help me out with the name of this game? Oh, I think I have to click on ask to unmute. Yeah, what's this one called?
Minecraft,
And what's so special about Minecraft? What can we build in Minecraft?
everything,
Yeah,
basically.
everything, everything. So it's a game where we can build things, and specifically, you can use coding. I think that's maybe one of the examples that I have some students who say, "Oh, I want to learn to write some Lua code so that I can build some stuff." And so I think that's maybe one of the examples that often students know that they can use code to create different worlds and things within the game. Okay. Um, all right. Any of the other examples on here? Yeah, Edward? Oh, sorry. Let me click on ask to unmute. Great, go ahead.
Hi, yeah. So in the top middle one, it's a picture of a drone, and the relationships between drones and coding is that drones rely on coding on operation, navigation, and functionality. So one type is if you're controlling it through a remote controller, it uses coding to take that data and process it and use its like sensors to move. But you can also code it to make deliveries, for example. I know some countries have use this technology to help with deliveries, medical supplies, or emergency stuff. So yeah, drones, there's multiple connections between drones and coding.
That's right. Yeah, definitely. And I think that definitely sort of thinking about what drones could possibly do to help us in our lives is it's growing and expanded, like you mentioned about the deliveries. Yeah, like packages or groceries or things like that could be delivered by drones. They can be used in other contexts as well. It looks like maybe this one has like a camera on it or something like that. They can be used in lots of types of jobs. And whether these drones are controlled by a remote. Well, how does it know to move forward or to go higher or lower, right? That's controlled through some instructions which get sent to the drone. Um, yeah. Okay, let's go to Susie. You have another example? Maybe let's do one or two more from here.
Um, um, on the third pictures, there are many applications, and we use applications in in our lives, and we use applications for many times, and we use code to make applications.
That's exactly right. That's exactly right. So this one in the top corner, lots and lots of applications. So whether those applications live on our phone, whether they are applications on our computer, there these are all things that programmers have set up some instructions on how we interact with these applications, and even expanding that into thinking about websites. Like for example, I'm on this website learn.xcamp.org. Well, someone had to, create these instructions of, hey, what should happen when I click on this, home button? Where does that take me, right? That's where a programmer would write some logic to tell what should happen in that case. Or for example, when I, change the visibility of my slides or other things like that, how should the permissions change or how should the slide look different? That all comes down to coding. So there's lots of examples here. And the one that we didn't talk about here is this one in the bottom left corner, which this is Pixar. This is referring to some animations. So animations are just simply like these like moving photos, right? If we think about photos and we were to move them and create little animations, that's simply all it is, right? And so those digital photos that are created sort of in that moving sequence are written with code, and we can sort of decide how these characters will move and interact with each other and other things like that through the power of code. So there are so many things that use code and require programmers in our daily lives that we probably don't really think about until we start writing code ourselves and see what are the kinds of things that we can do. Okay. All right. So let's look at some of these coding languages. So I'm not sure if you guys have heard about this before, but there are lots of different languages. Just like, for example, I'm speaking to you in English. I could be speaking to you in, Spanish or French or something like that. There's different ways in which we write our code. And for those different languages, there's different use cases or purposes. There's not just one way in which we can write our code to be interpreted by the computer. So the one that we're going to focus on today is called Python. And I'll explain in the next slide why that's the choice our choice for today. Another nice language that we like to learn in XCamp is C++. Now, that's a language that's really popular in competitive programming. I'm not sure, has anyone heard about competitive programming or maybe heard about USECO or other things like that. And maybe not so much. You guys are a little bit on the younger side. Oh, a couple students have, yeah. So it's a really popular language to use in competitive programming because it's really, really fast. And then Java, for example, that's another really big and popular language to use. A lot of companies and stuff use Java to build their systems. And then we can see there's some other ones in the bottom. For example, a relatively newer language like Golang. And then we have our sort of language of the web, which is JavaScript, and maybe a lesser known one called Lisp that I'm sure not too many people know about. Okay, but yeah, there's lots of different choices for us to choose when we are beginning our programming journey and sort of thinking about what we want to build and why. So why are we going to learn Python today? And why do we learn Python when we start in XCamp class? Well, the reason is because it's really beginner friendly. And that's because it looks, and you'll see when we start writing our Python code, it looks a lot similar to the way that we would sort of speak English. So it's an easier transition. There's not a lot of like special characters or fancy syntax that I need to get to understand in order to start writing it. So that will allow me to start writing code a little bit faster than if I were to use a different programming language. And then the other purpose is that Python in our modern day, Python has a lot of really useful cases to it. So for example, like a lot of artificial intelligence uses Python for the way it's designed. You could even use Python for like web development. It's very, very common for like data analysis and other things like that. And now Python's kind of evolved to this language where it could be used for a lot of different things. And there's pros and cons. We won't talk too much today about the pros and cons. But if you are interested in programming, it's a really, really great place to start because it's easy to get started and it will allow you to be able to work on a lot of cool things. So now is the part where we get to write our very first Python program. So if you already have your Thonny editor set up, then this is the part where you will open your Thonny editor. So I can go to my Thonny editor. Hold on, and let me bring it into the view. And so I have my editor, and I can take this code here. I'm going to take this code, and I'm going to bring it into my Thonny editor, and it just has this word print with some parentheses around it. And then inside of that, it says hello world and it has some quotations here. Okay. So that's what I'm seeing when I'm looking at this. And I'm going to click the play button. I'm going to click the play button and I can see my message down below at the very bottom. Okay. So hopefully you had a chance to try that out. Now, what should you do if you don't have your editor set up? You didn't download that, or you're having some problems. That's okay. You can still follow along in the class today. There's some different options of like online editors that you can use to write some Python code. So for example, this one here is called Python Sandbox. And this will allow us to write some Python code. So I'm just going to copy the same thing and write hello world. And I can just hit the play button and then I can see my output here. So if you can follow along in the Thonny editor, that's really great. If not, and you still want to test out those commands, give it a try in this one here. Okay. So unfortunately, for the sake of time, I won't be able to go student to student and help you to fix your environment if you're having some issues. But you definitely could ask some questions in the chat. Okay, so let's keep going. So let's talk about what happened when I hit the play button. Hold on one second. Let me delete the annotations and okay, cool. All right, so what happened when I clicked the play button? Well, we saw at the very bottom here, I'll make it a little bit larger. When I hit the play button at the very bottom, I can see my message is displayed exactly as how I put it inside here. And if I were to change this to hello, I don't know, like my name or something like that, and I hit the play button and run, I can see my message changed here down below. So if I observe what's happening here, I can see that whatever message I put in between my quotations gets printed, it gets shown down below in this window down below. Okay, so that's what's happening there. Now this window that I'm seeing, it's printing out some text, and you may be thinking and sort of going back to the examples and saying, well, Teacher Brendan, you said, we can do all this stuff like create games and make apps and other things like that. And so what I did right here is a little bit different, right? I just was, printing out some text. I'm really, if I want to go to a game or a picture or other stuff like that, I need some like graphics or some window where I can draw and hopefully some commands that can help me to do that kind of thing. So in order to jump right into that world of being able to be able to draw and have some graphics that we can see with my code, we can use a library called Python Turtle. So this is probably where you're saying to me, I don't know what is a library, right? You probably only know what that means in the context of books. So for example, in our regular library, when we want to learn some information or be entertained by some books, we would go to the library and we would go select the books we want, and we can bring them home and read them, and when we're done, we can return them. And from those books, we can get some information from them. We didn't write the books, we didn't create the books. We just go to the library to take what we want, and from there we can learn that information. And with programming, this idea of using a library is very similar, where we're not going to write a bunch of code today about how to set up a window to display some graphics and how to move and change the colors and all that stuff. Because there's this very nice library called Python Turtle that we can use, and we can import this code, or we can bring this code into my file, and from there I can use the commands that they have set up in order to be able to create these really nice drawings. So the whole purpose of this is that we are going to be able to get started right away with making some drawings without having to write very much code at all. And so that will make our life a lot easier, and we can do some really fun stuff in only a matter of a few minutes, okay? So that's what we're going to do. So how do we write our very first Python Turtle program? Well, we need to collect that library. It's like the same idea of checking out your library book. And we do that with this special word in Python called import, okay? So if I go back to my code here and I do import, look how in my editor, it changed colors. And because this is a special word or a keyword that Python understands. So Python understands this word to mean something specific. And in this case, it's saying, oh, okay, you want to collect this library information, which you can then use, okay? And now what do I want to do? I want to start using that library. So I'm going to copy this line here, and we'll talk about what it does here. So this comes from my Turtle library. So notice how I use the same name. And then I use this dot after to represent, I'm going to use some sort of command from that library. And this next part here is saying, hey, Python Turtle library, I want you to create me a turtle. Okay, so if you're a little bit confused about why turtle or what that has to do with drawing, we'll get there in a second. You will see why this library is called Python Turtle. And I've named my turtle Ted. So that's why I wrote Ted equals. Now I could name it whatever I want. It could be T, it could be whatever name means something to you. We do have some names in Python about like, for example, we can't start our name with numbers, and we can't have spaces between our name, but a nice simple name where all the characters are together should be sufficient for this case. Okay, I forgot to run my code here, so I hit the play button, and let's see what happens. Oh, I gotta hide this so you can see. But look, I have it's this new window that pops up. So before, when I was writing my print line, I was seeing that down below, I was able to see my message, my text. But in this case, this library that I used helped me to create this new window, this special graphics window. And this is where we're going to be able to create some drawings. So in this graphics window here is, I didn't write the code in order to create that window, that comes from the setup, but I will be able to use that to begin doing some drawings. Okay. All right, so now we'll be able to choose our turtle shape. So this is the part of why turtle will make a little bit more sense. So I'm going to copy this part here, and I'm going to change my turtle shape. Here, I'm going to write my turtle's name. I'll write the dot to represent that, I want to use a command on this turtle. And this specific command is called shape. And inside of it, I'm going to write the shape that I want it to be. Now, this requires that I not just put any type of shape, that it matches what the library would expect me to put into it. So in this case, I'm showing you some options, but let's just put this turtle one first to see how this works. So I run my code, let's go to my window here, and there's my Python turtle. I did it, I created my Python turtle. So why is it called Python turtle? Well, because the idea of this is that we have this sort of turtle, or this cursor of our position of where we are in our graphics window. And what we're going to be doing today is we're going to be moving that turtle around the screen. And wherever the turtle walks, it's going to draw a line behind it. And so our turtle is kind of, you can think about your turtle as a pen. This turtle is going to be the pen that draws our picture for us. And hence the name Python turtle. Okay, so there's other options as well. If you want to, make it look like a circle or a square or a triangle, you can simply take that name. You could take that name and you can go back and you can change it like this. And when you run your code, you'll be able to see the shape that you want it to be. Okay, so I like the turtle one, so I'm gonna go back to that. Okay. All right, great. So let's see what are the kinds of things that we can do with this turtle in our drawing. So we can move our turtle around the screen. So what I'm going to do is I'm going to follow the instructions. I'm going to say, okay, I'll call my turtle by its name. I'll write the dot to show that I want to use some command on this turtle. And then once I do the dot, I can write some command here. So there's a command called forward, F-O-R-W-A-R-D. And if I put a number inside of here, it's going to help me to move. And let's see which direction is forward, how it moves me around the screen. So it looks like it moved me to the right of the screen. So there's a couple pieces that we probably want to understand. Number one, we want to think about, what does 100 mean? When Teacher Brendan wrote 100 in his code here, what does that mean in terms of, like, are we talking about centimeters, inches, some other unit of measurement or something like that? How can we sort of understand that to be able to have a better idea of what number we want to put in to make the subsequent line length that we want? And then another thing that I think is pretty interesting to think about is, I told it to go forward, but look how it's moving me to the right here. So I would think, if I were just kind of trying to understand this, I would say, well, wait a minute, how come I didn't say Ted dot right to take me to the right? How come forward meant going to the right? So I'm just curious, does anyone want to raise their hand and try and either maybe you know and you can raise your hand and you can help out the class, or if you would like to make a guess about what you think 100 means, or why you think forward means going to the right, then yeah, you can help us out. Okay, I think Daniel had his hand up first. Daniel, can you help me out?
Yeah, so for the forward, it's based in the direction of where the turtle is pointing when you instantiate the variable. And the what was the other question?
Oh, what does 100 mean?
Oh, it's like pixels. Yeah.
Pixels. Okay, so we'll have to talk about what a pixel is. And you said when we create our turtle, you used a nice programming word, instantiate our turtle. That's creating our object. But in this case, when we create this turtle, it's naturally facing towards the right. So how do we know that? Well, let's take away this code. Let's delete that code, and we'll run my program again. And I can see, look how the head of my turtle is facing towards the right. So that's the reason when I tell my turtle to go forward, that it's going to the right, is because that's naturally the way that it faces, okay? And if I have any mathematicians in the room, then if you kind of think about this as a coordinate plane, and you sort of, let me draw quickly for a second. You think about this as like an XY axis. You can sort of think about this as he's moving forward in the positive x direction. You can think about it in that way. Okay, so that's why he's moving that way. And hold on, let me clear my drawings. Okay, and the other question we had was, like what does 100 mean? And 100 meant pixels. And so that's what we have to understand is, well, what is a pixel? How do we know how much that is? So a pixel is a unit of measurement. As you probably know, different units of measurement like centimeters or meters or inches or feet and other things like that. This is often a unit of measurement that we use when we're looking at screens and we're sort of thinking about some sizes within some screens. And a pixel is roughly about 1/96 of an inch. So that is very, very small. And these pixels are essentially these tiny, tiny little squares. And these in our computer screen, they emit some light or some color. And because these pixels are so small and very closely put together, we don't actually see them. So even what we're looking at right now, like for example, I'm looking at this text from my slides, and I don't see any squares. But if I were to be able to sort of get in really, really close to see what's happening, I would be able to see these tiny, tiny little pixels, and it would look like this picture right here. I would be able to see that everything is made up of these little squares. So when we say to our program, hey, go forward 100, what we really mean is we're saying, hey, go forward by 100 pixels. And so that's why we move it that far. Okay, so if I go back to my code and I say, let's move forward 200, so we should go twice as far. And I run my code again, and we look at my window, and it went even further. I went 200 pixels in this direction this time. Okay. All right. So, like I said, these pixels, they give us this illusion that we have this smooth image, even though if we were able to look in really closely, we would notice that it's actually not. It's actually not. But because we're looking at it far away, and because the pixels are so small, we get that illusion for ourselves. Okay, that's pretty cool. You're saying, okay, Teacher Brendan, I can move forward with the turtle. What else can I do? And let's start putting some color here. And so what I'm going to do is I'm going to change the pen color with this pen color command. Okay, so what I want to do is, I guess before I even move forward, let's change my pen color. And I'm going to do exactly like the slides show me, and I'm going to change it to red. Now, just like when we saw that example of the turtle shape, it expects a specific color name, okay? And there's some acceptable names from the library that we're using, and I've put some of them below so that you can see them. So for example, if I use red, I can see that the line drawn by my turtle is a red line. Okay, if I were to change it to one of the other colors, I would see that it would change with that. However, if it's some color that is not able to be understood. Let's say I'm thinking of some random color or something like that. It's gonna give me an error. It's gonna say, hey, that's a bad color string. That doesn't make sense, right? I don't understand. So for that, we have some named colors, and I provided them below. There's a lot more of these. And then also within this Python turtle library, we have the ability to change colors and create colors using these RGB values. I'm not sure how many people have heard of this idea of RGB or red, green, blue values, but it's our computer's way, our graphics way of being able to represent every single possible color that we could potentially need simply by combining different amounts of red and green and blue. So we're not going to learn how to do that part today, but in our XCamp class, we would learn how to be able to do something like that. So today we'll just stick to these name colors because it's a little bit easier and simpler for us to do. All right, what's next? How can we turn? How can we move around the screen? Well, we can do that by using using a command, but as well, we are going to use some mathematics. So hopefully everyone knows a little bit about some basic geometry about different angles. And specifically, I'm going to represent the way that we turn in degrees. So for example, if I were to say, hey, I want you to turn 365 degrees, that would simply mean that you spin around and come all the way back. So that's the idea of what we will use today. You don't have to know too complicated geometry for today. So we're going to do some turning, and the way that we're going to do that is with this right command, okay? So I have my turtle, I have my pen color. I'm going to move, let me change it back to, let's say, red or something like that. And now let's turn to the right. So I'm going to call my turtle by his name, and I'm going to put the command for a right and how much I want to turn. So if I'm turning 90, then that would mean that I should go like this. I should go on an angle 90 degrees and go in the not in the completely opposite direction, but to the side from there. So if I run my code again, I can see. Do you guys see? I don't know if it's too small on your screen, but do you see how the head of my turtle is facing in the downwards direction now? So my turtle is now facing in the downwards direction, which means that if I go back and I do another ted.forward command, and I say how far he wants to go, let's say 200 again, then this should make a nice little like upside down L shape. And here's my upside down L shape. You can see sort of how I connected it. So in that case, I can use this in order to turn in different directions that I want to. Okay, here's a question for you guys. So there's more than one way we could have moved to the left. Okay, so we have a right command and we have a left command, but does anyone want to raise their hand and maybe be a little clever and help me out and think about, if I didn't have a left command, how could I also go to the right? Oh, yes, Claire. You want to help me out?
Right to 70.
Yeah. So that's sort of using our geometry. So let me back up so we can see here. So for example, hold on, to 70. And so that's kind of thinking about the angle in which we could take to wrap us all the way around it and get to the other direction. So it might be a little bit fast, but let's see if we can pay close attention and watch our turtle turn. Maybe let's see if I could. There, did you see the turtle, the way it spun all the way around and then started facing in the upwards direction? So yeah, pretty cool. That's just using a little bit of math. And then also, I also, if I really want to be clever, I can use the fact that, we can think of like negative angles, right? So I could also go in the negative direction. So if I'm going in the negative direction, if I were, facing the right and I'm going to the negative direction, that should take me in the backwards direction, which should really take me towards the left, right? So if I run my code again and take a look, again, this will take me in that upwards direction. This took me in the negative direction, 90 degrees. So, okay, I made it a little bit fancier than it needed to be, but we can keep it very simple at just simply turning right and left and placing a degree number in order to help us move in a specific direction. So again, no expectations that you really have a strong background in geometry, but in order to play around with this, we do need to know a little bit about angles. And so, you know, this 90 degrees is sort of changing in that, you know, going from the side to going up. 180 would be to wrap all the way around to the other side, and to do a full circle and come back to our starting position would be to go, you know, 365 degrees. And so from this picture, we can sort of see the different angles of how we, you know, the circle of how different angles would take us in different directions. And so you could sort of use this as an idea of where different angles are. Okay, so we won't need too much of this today. We just need to turn in a 90 degrees for what we want to do next, which is this first part here. So what we want to do is we want to look at this picture here and say, hey, all right, we have some commands that we learned in order to move forward and to turn left or right. I think that we have enough in order to create ourselves our very first square. So let's do the following. Let's take a look at this photo and see if we can recreate this as close as we can to the exact photo. Now, it's hard for us to see sort of how many pixels are used for the width of this, so you'll have to just sort of play with that to make it your own, but see if you can get it an exact square. And even if you could take it one step farther and see if you can have your turtle facing in the exact same direction as the one from the photo here. Okay, so let's take about you know, 3 or 4 minutes in order to try out this exercise. If you are a little bit stuck, please don't panic. I will make sure that I do this exercise together with you after. And so, you know, if you can't figure this out, no worries. I will help you guys for this first one, especially the very first exercise. When you're not quite sure what to do, it can be a little intimidating. Okay. And you know, if you're doing the exercise and you're following along and you wanted to use that Python sandbox, just make sure to switch over. You're not going to be able to do your turtle. It doesn't have the graphics, you know, package that we need. So you just have to come to the mode here and go to the turtle mode. And then this will give you a window in which you can write some turtle commands from here. So just a heads up, if you are using that Python sandbox, just make sure to set it to that turtle mode instead. And then from there, you can start writing your code like this. And it actually gives you a nice bonus command that I didn't show you guys yet about the speed. Okay. All right. I guess while I'm waiting for some students, maybe I can answer some questions. I see some students have questions. Callie, do you have a question?
Not really.
Oh, not really? Okay. Okay.
I like.
Okay. No worries. Well, if you do have a question, you can raise your hand again. I can try and help you out. Okay. How about Edward? Do you have a question? Can I help you out?
Yeah, so if we finish early, do we usually share what we did, or do we just wait until everyone finishes?
Good question. So normally in the XCamp class, when we do these practice type exercises, what you would do is you'd complete the exercise and then you would submit your code. And then once everyone is done submitting their code, then we would review it together. And if you're a little bit quick and you're able to do the exercises quickly, well, in this case, what you could do is you could play around and sort of see some of the different things that you could create with these commands. Or, you know, you also could just sort of, we're not going to take too long. You could also just wait patiently and sort of give yourself a little 1 minute, 2 minute break to let your mind relax before we do some more practice problems, okay? Okay. And Kelly, did you think of your question? No? Okay.
Submit the code.
Oh, I'm sorry. Can you say that a little louder?
How do you submit the code?
Oh, I'm saying in the normal XCamp class we would submit our code, but for today we have a lot of students and not as much time, so we're for the sake of time and just for this being the sample class, you know, I'll let you at the end there's some exercises that you can submit, but these ones here we're just gonna, you know, do on our own. Okay. All right, cool. Last question quickly, Iris. Yeah.
Yeah, so we missed the beginning of the class. So where should we do this?
Oh, where should you write the code?
Yeah.
Oh, good question. So if you were able to see the email and the setup instructions ahead of time,
Oh,
then you would have a Python Thonny editor that you could
okay.
write code in. If you
Okay.
didn't see that and you were not able to do that, that's totally okay. And so if you still want to follow along with the practice exercises, there's this website, pythonsandbox.com, that you can use. And right now we're using the turtle mode. And so you can just sort of follow along with what I'm doing right here. And that
Got
way
it.
you can just wait until after the class and do the setup and be able to
Yeah.
you know, still have some fun and participate. Okay.
Yeah, great. Yeah, thank you.
No problem. Okay, so let's go back and see if we can do this. So, all right, let's see if I can do this. All right, I guess I don't want my turtle to be shaped like a turtle because it doesn't look like that. So it looks like I'm gonna go forward. So I'll call my turtle and I'm gonna move in the forward direction. I don't know, let's say 200 or so. Then I'm gonna do my turn and I'm gonna turn to the right and that's gonna face me in the downwards direction. Then what I'll do is I'll go forward again. Okay. And since this is a square, what's going to happen is that all my sides and all my angles are going to be the same. So I'm going to make all my sides 200 pixels in length, and I'm going to make all my angles, they're going to be 90 degrees. Okay. I'm going to do my right turn again to take me to face the next direction. Okay. Then I'll go forward again by 200. Okay, and this is almost there, right? If I look at my picture so far, I'm almost there, and I just need to finish it off with one more turn and one more forward command here. Forward. Okay. Okay, this looks pretty good. And all right, if I want to be super accurate, you'll notice that actually in the drawing they did this one more right turn 90, right, to make it exactly the same. And we'll see why in a second, why it turned out to be that way. I guess if you're just replicating it, you don't have to do it like that. All right, so that looks pretty good, right? I was able to create a shape. And I would argue that, you know, with what we've learned so far here, we could create some other shapes as well. So let's see if we can do this one now. This one I think is a little bit more challenging because it's not just the like, I guess when you look at my code from here, you can see I was just kind of doing the same thing over again, just forward, right turn, forward, right turn, forward, right turn. So let's see if we do this one here. Let's give about like 2-3 minutes or so. If you get stuck, don't worry, we're gonna do this one together. Yes, William, do you have a question?
How do you repeat like a string of code?
That is an excellent question. And you are about 5 minutes ahead of the class, so we will get there. It's just a couple slides down. It's right below us. So if you're wondering, you're saying, "Hey, this looks really repetitive. I'm doing the same thing over and over again." You are right, and that's awesome. You're already thinking like a programmer. Programmer thinks like, "Hey, how could I do this in an easier way, in a simple way?" And so we will get there just in a moment. So yeah, excellent question. So I'll give you just a little time to sort of think about it and see if you can you know, sort of piece together. I think, you know, when you're recreating these photos, the best thing to do is sort of like think about the possibility. So I'm thinking about, all right, so my turtle ends up at the bottom and it's in an upwards direction. So maybe from the previous command, it was all the way at the top and they just sort of, I don't know, moved in that direction. So well, we might have to go back to our slides and be a little bit creative with our commands turning left and right and maybe even using our you know, using our forwards and our backwards, right, to move forwards and backwards. So we can try and do something like that. Okay. Yes, Victor, do you have a question?
I'm using the Python sandbox,
Okay.
and when I do the forward command, it says, let's do it again. Shoot. It says, but it says name error. Name forward is not defined on line 4.
Step 1, are you making sure that you're in the turtle mode?
Yeah.
Okay, and you have something that looks like this. Import turtle, and then here's the name of your turtle.
Yeah.
And then you name it exactly the same as the library. And then you write this one here, turtle with a capital T.
Yeah.
Can you see this and maybe double check your code and see if it matches?
Oh, okay. Yeah. I think I know what's missing
Yeah.
now. I forgot the name.
No problem. And it's actually really funny because that realization that you had there, it happens all the time when we're writing code. It will never go away. No matter how far we go in learning coding, there will always be that realization of, okay, I just figured this part out. I understand what I was doing wrong. So that's a good thing. That's something that we will get very, very used to when we're writing our code. Okay, let's come back together and let's figure out how to do this one. So I'm going to use maybe what I'll do is I'll just simply go forward first, and I can turn and then go forward again, or maybe I can try out my backward commands like this. Let's see what happens. So if I'm going backwards, I think I need to go, well, going backwards 200 would just take me towards the middle again. I want to go all the way and do the left side of my plus sign. So maybe I go like double that distance. Okay, let's see. Maybe I can see. Okay, so it kind of went, I guess it was a little bit difficult to see, but it went like forward and then it went backwards double the distance. And now I can do maybe one more forward like this to get me back to the middle. And then what I can do is I can go turn. I can turn upwards. So I'll do TED dot left to turn me in the upwards direction. 90 degrees. Okay, so let's take a look at how that looks. And do you see my turtle's ready to go? He's in the forward position. And then I'll just simply go TED dot forward, and I'll go forward by 200, and I'll just do the same thing. I'll just go backwards by 400 like this. Okay, so I'll go back by 400, and this should take me all the way to the very end. All right, that looks pretty good. It looks like their pencil line is a little bit thicker than mine, or maybe it's just zoomed in a little bit more. But it looks pretty good. It looks pretty good, just like the photo from here. Cool. All right, so now we did two shapes. We did this square, and then we did this plus sign here. But as we pointed out, you guys were really on top of this. This code that we wrote for creating this square, it was just me doing, well, I guess I didn't use copy and paste, but I probably should have used just copy and paste. I should have taken my two lines like this. I should have just said, okay, here's my two lines. Well, the square is going to do the same thing over and over again. So do there and there and there, and then that should fix my problem, right? Just a little copy paste, and it'll take me back to the beginning again. Which is true, right? But now I'm doing some repetitive work, and maybe there's a better way. And actually, this is one of the tasks that computers are really good at doing, which we rely on computers a lot for, which is to do repetitive tasks or things that would be very challenging for a human to do. Actually, a computer can do, with a lot less work. So if, for example, you think about like take the example of a calculator, right? And you hit a bunch of numbers and you like multiply them or divide them. It can do that instantly, right? And where we can be very skilled with our math, we often can't do those very complex big calculations so quickly. And that's where computers can do those types of tasks, like quick calculations or repetitive work, to help us out. And then we can just focus on the logic, and the computer can do the work part of it. So how are we going to do that? Well, we're going to do that with something called loop. So what we've been writing so far is just simply some commands. And when I hit the play button, Python's going to start from the very top. It's going to go from line 1 to 2 to 3 to 4 to 5 to 6. It'll read each line one by one, and it will execute the instructions that I gave it. So for example, on line 3, I told it to create a turtle. And then on line 4, I went forward. And then after that, so on and so forth. What you'll notice is, for example, if I were to take this command and I were to put it before, and I run my code, it's giving me an error. Ted is not defined. It says, I don't know who Ted is. And that's because it's going from the top down, right? It's saying, okay, well, I don't even know who this turtle Ted is because I don't read that instruction here until line 4. So that's what's going on there. However, if we want to sort of skip this and say, let's just tell Python, hey, please repeat these specific set of lines over and over again, we can do so with something called a loop. And so I can copy and paste this code here. Hopefully the indentation works. Let's see. Not quite. Okay, indentation is pretty important in Python. But I have this keyword for, look how it changes color in my editor. So I write for I in range 4. Okay, so I'm just saying, hey, repeat this block of code. I want you to do it 4 times. I want you to do ted.forward and ted.right. And actually, I deleted my code for my turtle, so I need to make sure I have that in place. Let's try that again. For I in range 4, so there's 4 sides to my square. Ted.forward. So here's my 2 important commands. By 100, let's say, and ted.right by 90 degrees. I run my code, I take a look, and it did the exact same thing of what I had previously drawn. But one of the advantages is that I only had to write these 2 lines of code, and on line 4, I just said, hey, Python, I want you to repeat those instructions. Notice how there's some pretty important parts, which is after I write the 4, this line with the 4 I in range, don't forget to put the colon there. And then the code that should be repeated needs to be indented. So I just hit the tab on my keyboard to push it inside. And that tells Python what belongs in this block of code that should be repeated. If I put, for example, this one to the outside like this, if I move it all the way to the left, notice how I get a different outcome here. So just make sure that whatever instructions you want to be repeated by the loop, that they are indented, what we call inside or to the right of the 4 word here. Okay. All right. So that kind of puts us in a position where there's a lot of things that we could do. These loops are really powerful, and we can use them in order to create different shapes and drawings and take us all over the place. We learn how to change the pen color, how to change the turtle shape, and honestly, this is just a very, very small portion of what we can potentially do just using this Python turtle library. So some of the fun things that that it would be awesome to learn if we had time today, but you know, this is just one lesson. It's not like 10 lessons. Is, for example, like we can use Python Turtle to draw circles, right? How would we draw a circle? As of now, all we did was draw some lines. Okay, how can we change the turtle speed? Well, actually, if you were using the sandbox, you could see that it had some template code to show you actually how to change the turtle speed so it can move faster and slower around the screen. You know, how could you do things like change the screen color? So by default, my screen color is just this white background. Well, that's a little boring. What if I want it to be green or blue or something like that, right? Well, we can do that with this Python turtle library. How about if I want to pick up my turtle, I want to move it to somewhere else on the screen, and I want to put it down and say, okay, go draw from there. Well, we can do that. We have a command in order to do that. How can I have my turtle draw something and then clear the screen? And actually, that's something that would be really helpful if we want to do some animations, right? We would do a drawing, we would wipe the screen clear, and then we'd have another drawing, right? So we can do that as well. How about how can I fill the shape of my drawing? So for example, when I draw my square here, how can I fill that in with some color so I can make it a little bit like nicer? I can create a better drawing. Would that be helpful if we had command, which we do. All right, how about some animations? Like I said, how can we make some animations? Well, step one, we start with our drawings. And then from there, we clear our drawing and make new ones. And what we can do is we can sort of create those drawings within a loop to make, you know, not just 1, 2 drawings that our animation would end really fast, but to display them really quickly and maybe do, you know, tens of thousands of drawings happening in a loop to show us some like really fast image to create some animation. So these are the kinds of things that we get to learn in the XCamp 100 class, and we get to sort of like explore the basics of the Python language, but then also have some fun using this library and draw some fun pictures and create some projects, make some animations and other things like that. So yeah, I think that it's really fun to just sort of create these drawings and play around with it and sort of see what you can make, especially if you like art or you have a little bit of creativity to you. It could be really fun to see what you can and can't draw. And I think that what you will learn, either if you go and look this up or you join the class, there's really you know, very few limitations there. If you're saying, hey, teacher Brendan, I don't think I could do this, you know, with the Python turtle drawing, you probably can, and you're probably just missing out on a command that you would use in order to help you out in that way. Okay, so what can we, you know, when we're talking about programming and sort of the magic of programming, there's a lot of cool stuff that's happening. Like, for example, we can see that these loops, they make our life so easy, right? Although we were just sort of saving ourselves drawing a couple of lines here. Imagine if I asked you, I said, hey, for your homework, you're going to draw a 35-sided polygon. Well, you're not just going to copy and paste the code, you know, 37 times. That would be really repetitive and you know, difficult. You would want to do that with a loop in order to make it a lot less code and make it easier for yourself. And so, you know, it's really powerful, some of the things that we can use in programming in terms of doing that repetitive work. But beyond that, we have, you know, other ways in which we can make our life easier, you know, by sort of finding shortcuts or finding nice ways of solving problems through something that we call algorithms. Okay, and so what an algorithm is just, it's just this like step-by-step recipe that your computer can follow. So the example that I like to think of is like, let's say, for example, someone told you, hey, I want you to bake a cake. And then you would say, okay, well, I'm going to go take this recipe and I'm going to follow the recipe. And step one is to, you know, get the eggs and combine them with the flour. And then someone else might be baking a cake and they say, oh, well, my recipe says, I need to take the flour first and then combine it with the eggs, right? So there's often different ways of solving a problem. In this case, it's baking a cake. And the same is true with some problems that we're going to see. There's different ways in which we can sort of approach solving these problems in sort of ways that would help in certain circumstances and making things easier than others. So where do we see these algorithms? So let's see a couple examples so that we can have a picture of really what's going on. So here's this picture at this bottom corner here. So what we can see is it's like this outer space scene. And there's this, it's very, very tiny. I don't know if you guys can see this, but in the bottom corner, there's this astronaut, and he is sort of entering this maze. And at the on the far side, there's this Saturn planet that he needs to arrive at. And so the question is, well, how does the astronaut get to the planet? Well, I guess if we were sort of, I don't know if you guys have played these before, but what you would do is you'd sort of like take your pencil and you'd sort of trace, and then maybe with your eyes, you'd kind of guess to see if you can find an open passageway and see if you can find a route to the end. And in this case, I think it's, not too difficult to sort of visualize just with your eyes and say, okay, it looks like it's open there and then maybe open here, and I can kind of go like this, right? That's not too hard to do. But some questions for us is, well, what if we were tasking our computer to do something like this? How would it be able to do that? Or what is even a more extreme case? Imagine you had a photo like this where there are hundreds of thousands of different paths that the astronaut could go down. That would be really hard to just look at that with your eyes and kind of have an idea of where it's trying to go, right? So that's where computers can come in, and programming in general. We can sort of create these recipes of saying, okay, try going this way, and if you get stuck, turn around and go back to where you came from, and so on and so forth. So it's not so easy to think about, but we have different ways in which we can tell our astronaut to explore this space in order to find the end. And those types of algorithms we get to learn in our XCamp 201 and 202 class in order to sort of learn like these different searching approaches to search the space in order to find something that we're looking for. Okay, so that's one example there. And here's another example. So let's say, for example, we were playing a guessing game. And the way that the game works is that I'm thinking about a number in my head, and you are going to try and guess the number. And each time you guess the number, I'm going to tell you whether my number that I'm thinking about in my head is higher or lower than the one that you guessed. Well, so how would you do that? Well, all right, I think of a number and maybe you say 1. Is it 1? I say, no, it's higher. Okay, how about 2? No, it's higher. Okay, Teacher Brendan, how about 3? No, it's higher. Well, if we're trying to get there at the fewest number of tries possible, you might be a little bit clever and say, well, if I guess right in the middle of the search space, if my number has to be between 1 and 100, and I guess 50, then right away, when I tell you either it's higher or lower, I can eliminate half of the potential possibilities. And now the new search space that I'm looking in only has half that many guesses that I can potentially make. And I can just continuously do that by cutting the search space in half and asking you higher or lower, and that will be the optimal way in order to get to the answer. And indeed, that's what you could do. And that's where we get this algorithm called the binary search. And this binary search is used absolutely everywhere. It's a very, very useful algorithm to find things very quickly when we have this space that we can search and it's organized, right? We can know if we need to go to the left or right. So this binary search is an algorithm that we get to learn when we visit some higher up level classes like 102 and revisit even at the 300 level and above when we see some more complicated examples as well. Okay, and so moving past those algorithms, we also, like I mentioned, we have some ways that we can sort of like represent some data with our code that we write. So just for example, when we were writing our code, we were creating some turtle like this. We often might want to represent real life things in our code. Let's say, for example, I wanted to represent a person or something like that, right? How would we represent that with data? Well, maybe, for example, a person has a name and an age and maybe a date of birth and some other information like that. And we sort of collect that information together to model this record that represents a person. And so let's take a look at this example here. So this photo in the bottom corner is some people who are waiting in a line for some boba tea. So they're waiting in line. I'm not sure if you guys can see it, that very small, there's this little kiosk at the front where you get to go and you get to punch in your order and you get to tell the person, hey, here's my order. Now, how do those orders get served, right? Why do the people who order first end up getting their drinks first, in general, depending on how long it takes to make your order. But how come those people, get to get their drinks first? And that's because this is representative of a data structure in which we call a queue. Okay, so if we sort of visualize that idea here, we think about that kiosk as the ticket counter, for example, where you get your ticket and you go wait in line and wait for your opportunity to collect your boba drink. So the first person in line, they're going to be at the front of the counter, and each person behind would be the next person ready as the line sort of progresses. So the first person in line gets served, right? They make their order, they get their ticket, and they leave the line to go, hang out and wait for their order. And what happens after that? Everyone gets to shift down and move up closer to the front of the line. And well, how if I want to join the line or to go make an order for my own boba, how do I do that? Well, I get to not just skip the line and go right to the front. I have to walk all the way to the back of the line and I have to be patient and wait my turn. So we actually have a data structure called a queue, which represents this structure where the tickets are being processed in this order of where if you are first, you get to be processed first. And if you're last, you have to sort of wait your turn in order to get to the front of the line. There's another data structure as well that is called a stack. And so here's this picture of the stack of books, and you can sort of think about this. If I have these stack of books and I want to grab one, let's say that's in the middle, well, how would I do that? Well, I guess you could just sort of rip them out. But if I wanted to do it in an orderly fashion, what I would do is I would take the book from the top, I'd put it down, I'd grab the next one off the top and put it down, and I'd keep doing that until I reach the book I need. And so I'd sort of start at the top of the stack, and one by one, I would be taking off these books in order to get to the book that I want. And we have a data structure that models that as well. And like I said, that is called a stack. And one thing that it's probably pretty difficult for you to think about because we don't have that experience yet. But actually, these two data structures, this stack and this queue, are tools in which we can use in order to go all the way back and solve this path problem here, where we want to say, how can we find the shortest path in order to get, or how can we find a path in order to get from the starting position of this astronaut all the way to the very end? So there's different ways in which you can do that. And like I mentioned, you can use the stack in order to create the different paths and directions. You can use a queue in order to create the different directions. And that's something that at this moment, since we don't have enough experience, it's really hard to picture in your head and visualize. But as we sort of build up the pieces of learning how to write code and learning sort of the fundamental structures that we need to first, then we'll be able to get to this point where we can, have all these different fun problems that we want to solve, and we can have lots of different tools from our algorithms and our data structures in order to figure out how to solve them. Okay, so yeah, that's I guess that concludes what I wanted to share with you today. So normally in our XCamp class, at the end of the class, what would happen is that we would leave the class and you would have some homework problems to complete. So although this is not like an official class, we do have some homework problems that you can try out if you want to. They're like maybe a little bit more challenging than the ones that we did in class. So especially if you want to, challenge yourself a little bit, you can give it a try. So for example, you can try and see if you can make this star, or see if you can use some loops and some colors in order to create some different, these are squares here. Do some loops in order to change direction and create some squares to make a drawing that looks like this. Okay, so yeah, like I said, normally what you do is in the learning site, you would be able to submit your homework problems there directly there. But in this case, we won't submit them to the learning site. But if you have the time and chance, I really recommend that you give it a try, because you definitely have the tools in order to do this. There's a couple, forward commands and turns. You might have to think about the angle and other things like that. But we know how to do these parts as well. This looks really complicated and fancy, but I promise you, we just need some loops, and we know how to draw some squares, and we know how to change the pen color. So we actually have everything we need in order to create something like that. Okay. All right. I know, Victor, you've had your hand up very patiently. Thank you for waiting. Do you have a question I can answer for you?
Yeah, like when I'm trying to repeat it, you said like for I in range 4, right?
Oh,
It
yes. Let me go back to my code.
says phase as bad input on line 3. The in is red. I do not know why.
So the thing that's really important is that with programming, we have to be very, very precise, or else our program doesn't really know what we're talking about. So even something as simple as, like, if I call my turtle Ted by accident with a capital T, with the human eye, I would say, well, why can't I understand this, right? Ted dot forward 100, right? And then my program complains, hey, Ted dot forward 100 with capital T, hey, Ted is not defined. And I'm telling my code, hey, wait a minute, I wrote Ted, I created my turtle called Ted on line 3. And this is like the little things that the human brain it could look at that, and it could sort of see words that are misspelled, or see sort of the intention, even if it's not quite correct. And it could, understand that, versus the program, it needs to be very precise. It needs to be exact in order, for that to help us. And now we have the power of artificial intelligence, and artificial intelligence can actually kind of simulate that same idea, where it could, sort of look at something that's not quite right and maybe help us find some patterns in order to make some suggestions or figure things out. But in general, just, keep in mind that when we're writing our Python programs, like, you wanna match things exactly as they're meant to be. So for I in range here, and then I write the number that I want, and then, like I said, indent to the next line, and then here is where I would begin writing my commands. Okay.
Yes, but I copied it, like the one you showed us, and it's still red. It doesn't. It still says it's wrong.
See if you could just simply hit the tab and then write your command like this. And Python is a little bit picky about the indentation, so see if you can try that out and fix your code from there. I think that's the solution of how you're going to fix this one. Okay. All right. Great. So that being said, we have completed our very first class. So I hope that you enjoyed my teaching for today. Like I said, my name is Teacher Brendan. I teach a lot of different classes at XCamp, and I really enjoyed being your teacher today. And I hope to see many of you in the future, either in my class, that would be awesome, or if not, maybe I get to go visit your class or see you in some class down the line. So great job, everyone. You guys were awesome class. And at this moment, I will turn it over to Charlie, and he will fill you guys in, and your parents specifically, with some more information about how XCamp works and the curriculum and sign up and